Good evening, everyone. Am I audible? Please confirm yes or no. Am I audible or not? Okay, so how was your day? And how was your examination, first of all? How was the exam? Not good? Didn't went well. It was great. Not good. Yes, you are improving. That's great. No, it's like from the previous exam, I think so. It's comparatively it's increasing, right? है ना? Yeah, so you are progressing. That's fine. Navneet 381. That's great score. I was about to solve round three questions. It was tough. Okay. Okay, fine. So it was for everyone. Nilanjan. Okay, Satvik, you are also having comparatively nice score. ठीक है. Okay. So, have you all gone any chance by going through what we have covered in the previous session with respect to recursion? Hello. Yes. Okay. So yeah, just tell me generic way, like generally I'm not targeting any one of you. Just tell me one thing that in which particular part you all find difficulties, whether it's like solving problems or with anything else, or which thing you feel that we should be focused on so that you guys can be improved with respect to your overall understanding of the computer concepts. What things you feel? Anyone of you can share. And Nana, how was your score? How was the exam? Okay, coding and DSA. That's like highly generic way. I don't want this generic. Like I want a particular thing in which particular point you want me to target on. Like not just me, everyone from the team you want to target on. Solving problems and understanding the test case. Okay, key concepts. Okay, fine. Okay, so just tell me one thing that how many of you are attending daily TA sessions? You are performing good in my session, but I just want to understand that how many of you are attending the sessions from the TA and asking the doubts regularly and solving the problems, solving the assignments regularly on regular basis. If you are doing that, then do you feel that in the exam anything that was not covered in the exam, anything that has asked that was not covered in the session? No, right? Hannah? So I think there is some lack in your practice. Like you want some more practice, right? Hannah? Okay. So I will suggest now. See, whatever is there is left, right? So we have to focus on the future only, Hannah. So for those who have scored really less marks, I can see the comments of some of the people have got the less marks, right? Some of the people have scored average marks, and some of the people have scored the good marks. Okay, so there is no issues in marks. I don't want that you are just focused on the marks, Hannah. I don't want that kind of way to teach. I want that holistic approach so that everyone from you would be benefit from that. Okay. Okay. So what I will suggest that I have already discussed in the previous sessions, many of the sessions as well. Try to solve, like, please allocate your 3 or 4 hours a day in the free time, in the regular days, in the weekends. Try to compensate that time on, like, each and every day you have to make a average of 4 hours. Okay, So every day you have to 3 to 4 hours you have to practice. You have to find yourself like in which particular point you are lacking on. Okay, so nobody will judge on your perspective. Okay, so you are the better judge of yourself. You have to judge, you have to decide in which particular portion you are finding difficulties. Gather that difficulties, work on yourself. Try to watch the videos from for the recording videos as well, from other sources as well. Okay, from the YouTube as well. Anything you want, just do it. Okay, anyhow you have to clear it, otherwise you will be in big trouble as time passes. Okay, so every day you have to spare some chunk of time. I will not give a number, particular number, because everyone is have a different kind of lifestyle right now. Some of them are working, some of them are attending the college, some of them are doing dual jobs, some of them are freelancing work. So I don't like, everyone has some other work. This is a part time for everyone, है ना? ठीक है? So you have to place at a better place. You have to place in a better company. You have to score really good marks in an examination, so that in the interview nobody will no push you back. Okay, so for that you have to work. You have थोड़ा extra effort तो मारना पड़ेगा, because if you are just doing what in the class we are doing, there is sufficient, but there is not enough for practicing. Okay, because we have some limited time. We cannot cover, we cannot practice in the class. We can focus on the areas which will be highly important, but we cannot cover 100% of practice here. If you are telling me that, sir, in the lead code I'm finding some difficulties in that, I can solve that. But this kind of questions you should be asking to me, to the TAs. Every Sunday we have, like bi-weekly Sunday we have doubt solving class. Ask the question in the class. Okay, so if you are failing in the test cases, that's fine. I'm saying right now that's fine. That's not entirely fine, but that's fine in at up to some level, because you are able to attempt the question. You have resolved some of the test cases. You are just left with some of the test cases. Okay, so you know the logic, but you don't know the optimum logic. That's the difference. Okay, so if that is the case, then it is fine at this level, but I will highly encourage everyone, please try to work on yourself. Okay, this is not for anyone, any one particular person. This is for everyone. Uh this is for entire of your life. Okay, so if I'm taking my example, if I give you, then I myself right now, if I'm in a good company, I'm having a good projects right now with me, I'm earning good, but still I am spending 2 to 3 hours average a day. I have a full-time job, I have this part-time job, and I'm teaching you as well, right? So after all of this also, I'm able to find some time for myself, because if you don't practice, you will, trust me, you will forget every concept as time passes. So you have to, like, you have to sharpen your blade like time to time. Okay, otherwise you will be not in a good zone. You will not feel good. Okay, so the main motto of doing this all is you will feel good if you are solving good questions, if you are performing good in your job. Then at the end of the day, like in your bed, you will have a good sleep. That's the main motto of your life, right? This is not for entire, like, this 9 months of course. This is for lifetime. Okay, so I'm not focusing on like just for 9 months and to place in your company. Of course this is the motto, but we should focus on holistic approach, just not for the getting the job and cracking the interviews. This should not be the case. Everyone agrees with me? So please utilize the power of TAs. Okay, because you guys are working, I know. Okay, I have taught, like, trust me, I have taught many students in my life. This is not for first time with me, right? I've taught around 1500 to 2000 people right now. Okay, okay, so I can understand from the batch review, from your comments as well, who is working on himself, who is not working. I can guess from your behavior. Okay, so I know this batch is really good as compared to other batches. So I can say you guys can do it. You just need, some push, some advice, some backing, some support. Okay, you have that as form of the team of an academy, the reliable, and in form of TA. Okay, so try to utilize this everything. If you do it, trust me, nobody will stop you. Not just for this 9 months of course, for entire your life. This will change your life entirely. ठीक है? Okay. फाइन, ठीक है. So can we start with today's session now? Any general query you have, you can feel free to ask me anytime. Okay. So I'm expecting all of you to score better. I'm expecting all of you to feel good each and every day when you are going in your bed to sleep. Okay. Fine. Okay. Okay. So in previous session in the recursion, we have solved some of the basic concepts, some of the basic problems. In this session, we will be focusing on some higher difficult questions. I hope you can see my OneNote screen, right now. Okay. So in the previous session, we have solved some of the basic concepts with respect to recursion. We have solved some basic problems as well. In this particular session, we will be focusing on some higher difficult problems. We will be starting although with basic, and we'll gradually moving to the advanced one. In this session, in the next session, we will be solving the problem with respect to recursion and the problem solving thing. Okay. Okay, so please do not miss any of the things with this and next session. And from the coming session, it will be highly important thing, because we will be starting the time complexity and space complexity. I know you guys know what the importance of that, right? Yeah, I'm covering that right now, Nishant. Okay, Fibonacci series, and one more problem is there also. I have given you the homework, I guess, so right, to think about the Fibonacci solution and one of more problem of the sorting. Yes or no? In the end, I just for 5 minutes I explained the problem statement. You know? So anyone from you have tried that, the Fibonacci and the sorting? You have to sort the array with respect to recursion. Any one of you have tried that? Right, Fibonacci, great. With help of recursion, right, Nishant? Okay, okay. So for all of those who have not tried, please try to cover at least try to cover entire thing what we have covered in the lecture. Okay, and try to solve the questions with respect to that. Trust me, we are right now solving the easy questions. It's like very easy question. I will not put that in a mark of easy question also, because this is not a easy, this is less than easy. Okay, so this is very easy questions. So gradually we will be moving to the easy questions and the intermediate questions and the advanced questions. Okay, so these things like we are in still, right, we have some time to get cope up with that. Any concept which you are not getting, feel free to ask any point of time. Okay, so on that note, we are starting right now the problem of Fibonacci first. Okay, then after we'll be solving some other questions as well. Let me put this. Yes. So first of all, we will be solving the Fibonacci series. Okay. So as you all know, we have covered this Fibonacci problem in iterative solution. Okay. In iterative solution. So what the Fibonacci series means that we have a series like this: 0, 1, 1, 2, 3, 5, 8, 13, and so on. Okay. This is my zeroth Fibonacci number, one, second, third, fourth, fifth, sixth, and seventh. Okay. Now, out of this, if I say that if my n is equals to 3, okay, then your output would be what? If my n is equals to 3, then my output would be 2. Okay. If my n is equals to 4, then my output would be 3. Okay. So likewise, if I tell you that you have to find the nth Fibonacci number. Okay. So your question here is to find the nth Fibonacci number. Okay. I hope the question is clear for everyone, right? ठीक है. Okay. Now see, now if you have this kind of question, then you have to, like, your bigger question is what, like we are solving this question with respect with the help of recursion, right? So your bigger question here, your bigger question here is, see, to find the nth number is your bigger problem, right? Now what is a smaller problem? So if you see the series, then suppose if you have to find the n equals to 3, right? Okay, so n equals to 3 does mean what? First plus second, that equals to third, right? So first step plus second step, वो मिला के हमारा थर्ड स्टेप हो रहा है, right? So can I say that if you find the nth Fibonacci number, that will be equals to your n minus 1 plus n minus 2? Can I say that? है ना? So your bigger problem is what? To find the nth Fibonacci number. Okay, so find the nth one is your bigger problem, and to find the n minus 1, also to find the n minus 2 is your smaller problem. Can I say that? है ना? These two are my smaller problems. So as my definition of recursion, we have to find, we have to bifurcate our smaller problem from the bigger problem. So we have identified our smaller problem. So your half job is done. Your half war is won. How? Because you just have to call this particular recursion solution again and again. So what will be my recursive solution here? So if I have to find my recursive solution here, then if I have my f of n, then my f of n minus 1 plus f of n minus 2 would be my recursive solution here. I hope everyone would be agreed with me with this particular term. This would be what? This would be anyway does mean that this is my recursive solution, right? Okay, right? Recurrence relation also you can tell if you remember from the last class. Yes or no? Right? Okay, okay. So if you are clear with this, then this is my recurrence relation, or we can say recursive solution, right? So now first of all, just tell me people that if you have to solve any problem with recursion, then what was our three main step? Our three main step, what first was what? Our base case. Second was what? Second was what? Self work. But I'll put this in a last term. Okay, I'll put this in a last because I'll tell you why. Second was my recursive call, and third one was my self work. Why I will put this self work in the third step? You can also put this in second, depend on your problem, but in this particular solution I'll put this in a third term, because after my recursive call, whatever this will be returning to me, then after I'll just make my self work. So can anyone tell me what is my self work here? What is my self work here? So Nilanjan, I told you that okay, please repeat recursive solution. Okay, fine. So if you see here, if I want to find n equals to 4, okay, so suppose my n जो मेरा है वो 4 है, ठीक है? So if I want to find n equals to 4, then if you see my answer is 3, right? So n equals to 4, answer is 3. That is the summation of what? The second step plus third step. Can I say that, Nilanjan? Right? So that's what my recursion solution is. So if you focus on the third, so my n equals to 4, then can I say that whatever my n in the third step plus whatever my n would be on my second step would be my solution, right? So my third step में क्या था मेरा n? 2 था. Second step में 1, right? So this would be my answer, right? ठीक है? So that is what I did here. So I just taken the last two terms, right? So f of n minus 1 plus f of n minus 2. This is what my recursive solution. So in any of the recursion problem, your main three terms are to find a base case, you have to make a recursive call, and you have to do a self work. Okay, this is what is expected from any recursive solution or any recursive problem, right? Okay, except the recursive call, what is added for or multiplicated is called self work. Yes, Rupesh is absolutely right here. Okay, you are in right path, Rupesh. Fine. So can anyone tell me, see, in any recursive call or in any Fibonacci series, your first two terms are fixed, right? So zeroth step is 0, 1th step is 1. So this is what my base case. You cannot go left side from this, right? So if you are standing at this position, if you are standing at this position, then you can find a solution of, like, you can add this two and make this. If you standing at this, you can add this two and make this. If you are standing at this position, then after you can add 0, but you can not add 0 with, there is nothing here, this is void here, right? There is nothing here. So this is what my base case is, right? Okay. So your zeroth step is 0, your 1th step is 1. This is what my base case is. Okay, because I cannot go left side from this. I cannot go, I cannot divide this particular solution anyway, right? This is my final eternal solution, right? Okay, so that is why we are calling this as a base case. You cannot go further from this, you cannot call anything from this. Okay, this is what is, like, नहीं बोलते हम लोग की हद आ गई. ठीक है, this is the final optimum solution of the recursive call of 0th step plus 1 step, right? So this is what something called as my base case. Now, if you understand this, then see, in every recursive call we can have a recursive tree as well. Have you heard about that? Have you heard about recursive tree? I'm pretty much sure you have seen that, but you don't know that this is called recursive tree. Okay, so what does mean by recursive tree? That does mean that, suppose, for an example, I need to find my fifth of Fibonacci term, right? So what I'll do, I will find f of 4. I will find f of 3. I'll just make addition of this two and find f of 5. I'll do that now. Yes or no? Right? So this f of 4 will further divide into what? F of 3 and f of 2. This f of 3 will be divided into f of 2 and f of 1. This f of 3 will be divided into f of 2 and f of 1. This f of 2 will be divided into f of 1 and f of 0. Yes or no? Right? Okay, this f of 2 will be further divided into f of 1 and f of 0, right? Okay, similarly to here, f of 1 and f of 0, correct? This is what my recursive tree is, right? Okay, we have seen that, right? Now, if you find a solution of everything, like, so this is my call stack. Okay, this is my call stack. I hope we have, you remember what is call stack. You have not, like, this not vanished from your memory, and now this is still there, right? You remember what is call stack, yes or no? Okay, so great. Okay, so if you know the call stack, then what we will do, first of all, we will be going at this step, my f of 5. So I'll be inserting this f of 5 here. Okay, now f of 5 will be further called what? F of 4. Okay, so my f of 4 will insert into the call stack. Okay, f of 4 will be called f of 3. So here it will be insert into f of 3. F of 3 will be called f of 2. It will be insert into f of 2. F of 2 will be called f of 1. So it will be insert into f of 1. Now at this particular step, since we are at the basic of the step, right? So it will be returning what? This is f of 1, right? So f of 1 will be returning what? 1, right? Whatever our n is. Yes or no? Anna? So f of 1 will be returning 1, right? Okay, this one will be carried out, this one will be returned to this. Now, since you have answer of 1, right? Since you have answer of 1, now you will find answer of f of 0. So f of 0 is what? 0. So you will make this plus 2, 1 plus 0, it will be 1. This will be returned to this. Now f of 3 will be go here. F of 1 is what? 1. So this 1 plus 1, that is 2, it will be returned to this 2, right? So f of 4 is what? This is 2 plus f of 2 is what? 1. So 2 plus 1, that is what? 3. So this 3. 3 will be returned to here. So since this is 3, f of 3 is what? F of 3 was what? What is was over f of 3 guys? 2, right? Anna? So f of 5 will be what? 5. Similar to this fashion it will be followed. Okay? Okay? So similar to this fashion it will follow, and it will be making care of, it will be taken care of like recursion. So whenever we were going at the deepest level of it, whenever we were going at the deepest level of it, let's say first of all what we did, we gone here, then we gone here, then we gone here, then we gone here, everything was inserted into it, then we returned from here. Okay, then we returned from here. So f of 1 would be gone because f of 1 stars is over, right? Now we, then after I gone here, right? So f of 0 would be inserted here. Then after I return from f of 0, I made plus of I made addition of this 2, I return that to here, right? So it will be carried out, it will be vanished out. Then after I also return from f of 2, so it will be also removed from this, right? Then after I gone into f of 1 level here, right? So it will be inserted here. Then after I return from here, so f of 3 will be what? 1 plus 1, that is 2. It will be returned to f of 4. So when I return to f of 4, f of 1 was, f of 1's task was done, also f of 3's task was done, so it was also gone through it. ठीक है, so right now I'm standing at f of 4. So f of 4, since I know f of 3, I will be going into f of 2, right? ठीक है, so I will be going into f of 2. So f of 2 will be insert here, f of 2 will be further going into f of 1. So f of 1 would be insert here. ठीक है, after I will f of 1 I'll be returning from here, so it will be removed from this. Then after I'll go into here, so it will be f of 0, it will be inserted here. Then after I'll remove, I'll be coming back from f of 0, I'll be coming to f of 2. So this will be empty. F of 2 would be, answer would be carried out to f of 4. F of 2 would be again empty, right? And f of 4 answer would be carried out to f of 5. So f of 4's task is done. F of 5 will further do the same process to going here, going here, going here, returning from here, going back to here, returning everything from here, going back to here, returning back to from here, and return back to here. And then after it will be carried out. Okay? Got it, everyone? Right? In tree also we will be looking the same way. We will traverse this from a same way. Okay? So how this is working, everything is clear, right? So if this is clear, then we will be moving to the implementation part now. Okay? So let me open my VS Code, or else let me open my Mozilla. Okay, just confirm once you can see my screen of Mozilla. Okay, there are so many branch. If is there anything specific method which branch it will follow, or which, or is this random? Priyanshu, we have not followed the random manner. If you remember, see, I'll be carried out everything here. I hope you are talking about this one, right? What we have just covered, right? Okay, so I'll be showing you again. Okay, this is very important. Please ask if you are not clear. That is completely fine with me. Now, see. Okay, this was our tree, right? Now what I did is, so this is followed by any recursion manner. Okay, any recursion problem, any recursion tree, this would be followed. You have to go first of all at the deepest manner. Okay, so first of all we will be taking f of 5, it will be inserted here. Then after we'll be going to f of 4, then after we'll be going to f of 3, then after we'll be going to f of 2, then after we'll going to the f of 1. This is the deepest root of the tree, right? This is the deepest root of the tree. Okay, then after we'll be, once we are reaching here, everything would be inserted here. Okay, so suppose f of 5, f of 4, f of 3, f of 2, f of 1. We know the answer of f of 1 because this is our base case, right? है ना? Okay, so first we have to go that branch which is deepest. Yes. For no, no. first of all we have to go at the left hand side. Okay, so suppose for an example, if by any chance this is on a left side, although right now my left branch is deepest, बट सपोज करो कि आपकी लेफ्ट ब्रांच शॉर्टेस्ट है राइट ब्रांच से, राइट? एट दैट पर्टिकुलर लेवल ऑल्सो यू हैव टू फॉलो द लेफ्ट एंड राइट, सो ठीक है, सो यू हैव टू फॉलो द लेफ्ट एंड राइट, फर्स्ट ऑफ ऑल यू हैव टू गो इन द लेफ्ट ब्रांच, देन आफ्टर यू हैव टू गो इन द राइट ब्रांच, वी विल बी लर्निंग दिस व्हेन वी आर लर्निंग द ट्री। ओके, ठीक है? Why we are not doing f of 0 after f of 1? We have to do it. Okay, so we have to do it. ठीक है? I did not do it because this is our base case. ठीक है? So if after you reach f of 1, it will not go to f of 0 because this is our base case. That is why I had not written here. Fine, got it? Okay. Yes, top to down and left to right. Yes. On left side, this one. Nishant, you are talking about this one. So Nishant, this is our base case, right? So we had written that whenever our n equals to 1 and whenever our n equals to 0, we have to return what? Our n, right? We'll be writing this because if your n is 0, then your answer is 0. If your n is 1, then our answer is 1. Everything would be based on this. We have to summation of that, then we'll make 2. We need summation of that, we'll make 3. So whenever you have your n equals to 1, let's say in this case f of 1, it will not go further to f of 0. You can write it on your writing time, but it will not go further because it will be returned from this only, because this is our condition, right? I'll be showing you in detail whenever we are writing the code. I hope this is clear why we are not going further with the f of 0, right? Okay. So, Ankit, if your f of like n equals to 6, then this same tree will be happened, but with the one more root. Okay, right? If a base case is not mentioned, then f of -1 and -2. So on it will never stop. Yes, Adish is right. So that's what I told you in a previous lecture also, in the many time ago also, because whenever you are using recursion, what you have to make keep in mind, I taught you this. Whenever you are using recursion, your stopping criteria or your base case should be so strong that it will not end up in a infinite loop. Otherwise, if your base case is not ready, suppose if you are not writing that 0, if whenever you are reaching at 0 and whenever you are reaching at 1, you have to return 0 from here, you have to return 1 from here. If you are not writing it, it will be infinite loop, it will be never ending process. Okay, I hope, like in the some of the session also we faced this, right? We did not write the base condition and it was going into the infinite loop, if I remember in your class also. I don't remember that. I did this in one time. Yes, it will be stack overflow. Okay, fine. So let us start. Let us start now the implementation part of this. It's pretty much clear, but still we have to try it. Fine, so let me go into the developer tools. ठीक है. So now, okay, so Nishant, in fact, case I tried if condition in last and it goes in infinite loop. Yes, it will go. Fine. ठीक है. Priyanshu, I'm not getting it. The flow branch. What do you mean by that? You mean that you need another explanation for this? Yes, f of 1 will be returning the value instead of going further. Okay, I'll be writing that. Priyanshu, can you clear up your doubt when it goes back? I'm not getting it. Can you please raise your hand, Priyanshu? This needs to be clear if you have any doubt. We can use memory method to avoid repetition of f of 2, f of 3. Yes, we can do that, but this is, I've just explained about the generic term, what how recursion will work. Okay, so yeah, Priyanshu, you can speak now.
So what basically I'm asking is like when we are returning from F1, can you open the screen where you have
Yeah,
found
sure,
the tree?
sure, sure, sure. Just a second. Can you see that?
Right. So I'm asking, like, when we go back from F1 to F2 and
Okay.
back to F3, then it will move to the right branch
Yes.
or
See,
not?
how it will be going through. So whenever you are moving back to f of 1 to f of 2, it will be first. It has to complete this internal. This is child. Okay. So f of 1 and f of 0 are child of f of 2, right? Okay.
Right.
So whenever you are returning from f of 1 from here, it has to complete this. Okay. So if you remember, if you have observed carefully, whenever I have returned from this, I also gone here to complete f of 0. Then after I return back here, once f of 2 task is done, every child of f of 2 are covered, then only we can move backtrack.
Then
Okay.
F3 followed by F3 will do the same. It will
Yes.
complete its
So
cycle.
if I have to draw it again, this is really important, huh? So whenever you are going to f of 5, f of 3, f of 4 to 3, 3 to 2, 2 to 1, then after I came back to f of 2, then after I gone into f of 0, then again I came back to f of 2, I gone to f of 3, I came back to f of 1, I came back from f of 1, I gone to f of 4, I gone to f of 2, came back from f of 2, gone to f of 5,
Uh,
and
when we gone to this F2, we also have gone to F1, but we already have
yes,
done that.
yeah, we have to go here, but there are some process which you can avoid. Suppose we have answer from this, you can avoid this, but if from initial purpose, I'll teach you later, but from initial purpose, whenever you are from f of 4, you have to go from f of 2, f of 2 to f of 1, f of 2 return back here, f of 2 to again f of 0, return back from here. After f of 2 task is done, you have to go to f of 4, you have to again go for f of 5, then same process will repeat from here, from this,
Okay,
like f
in
of
the
5
right
to f of
branch.
3, then 2, then 1, then came back from f of 1, then go on to f of 0, then came back from f of 2, then again
So,
go on to f
like,
of 3.
we already got the answers in this of this F3 and F2 in the left branch. So it will follow this, like, going into in the right branch or not.
Yeah, it will
We
go,
have.
but there are some criteria which you can, like, you can omit to followed by this. But all and all, if you have some other values also, like for an example, just consider not this, just consider like this. Okay, like a, b,
Okay, if we
c,
have
d,
in right branch,
e.
if we
I'm
have
just
something else.
explaining, yeah, I'm just explaining the holistic approach for this, like e, f, and h and I. Okay, so if you have this loop, okay, if you have this kind of thing, if you have this tree, not loop, if you have this tree, then how the traversal will work? First of all, you have to go to a from b, b dot d. Let me take some smaller pen, it was too big. Okay, so first of all, you have to go from a to b, b to d, came back from d, then see here, then came back from here, then go on here, then here, then here, then here, then came back from here, then here, then came back from here, then here, then here, 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 came back from here, here, and finally it will return like this. Whenever we are learning the tree, I'll be explain once again this entire process how it is traversed. Okay, this is something called as tree traversal. Okay, in that I'll will be also writing the string of this, like a, b, d, then c. So if you see here, we have followed the same process. Okay, so now just see what we have followed. We have to make a string. This is a problem. Okay, this will be a problem statement when we are learning the tree. So this is how, that is how, like, recursion problem will be covered. Okay, so first of all, we have to go from b, this route from d, then came back from here, then here. So if you follow this, like, this is my traversal string, right? First of all, I came gone to b, then I gone to d, then I came back from here, then I gone to e, right? So this is e, not c. Okay, this is my left route, this is my left trees traversal. Same way we have to follow the right tree traversal. Okay.
Okay, got
Okay,
it.
fine.
Thank you. Yes.
Yeah. Okay, so let us start with the implementation part. Okay, fine. So since we are implementing the Fibonacci series, right? So can anyone tell me, like, let's say if I have a function, okay, function O n, Okay. Inside this, my base condition is what? If my n is equals to 0, or if my n is equals to 1. Okay. So I need to return what? In this particular two cases, I need to return what? Whatever my n is. Yes or no? Right? In every other case, this is my what? My base case, right? In every other case, I need to make a recursive call. So let response 1, then I will call this Fibonacci series again with n minus 1. Let response 2, I'll call again this Fibonacci series with n minus 2. I'll make summation of this particular all of this. Let response is equals to response 1 plus response 2. So there are, if you observe here, there are two recursive calls, right? There are two recursive call here. Okay. So, and after this, after finding the recursive call, I need to do my self work, which is what? Adding this particular two answers, right? And after that, I just need to return a response whatever I have. Cool. Okay. And after that, I just need to what? I just need to call it console.log uh, fibo of, let's say, 5. If I have to write it, then this is nothing but my base case. This is nothing but my recursive call. Again, this is what my recursive call. This is what my self work. It is as simple as this. Okay. I hope you guys can relate with it, right? So if you observe, like f of 5 was what? 5. Okay. This is, I think, so clear to everyone. If you have any doubt, please ping me up. Guys, are you clear? Meanwhile, I'll just open my VS Code and copy the things. Okay, so I'll create a new file for this. Today is 13th of June. Okay, so any sorts of doubt, people? Yes or no? Guys, am I audible? Okay, so sorry. I was not seeing the questions, the comments. Okay, okay, fine. So line 7 8, repeat again. I'll repeat that. Just a second. Let me see the previous comments as well. Just a second. Binary search tree. Yes. Okay, fine. Yeah. So yeah. So okay. If Fibo phi, it is index of Fibo series. Yes, phi is my index. Okay. So we have a Wi-Fi. You can tell like steps. Okay, Nilanjan. Just like my step was fifth, then I got answer of fifth. Okay. So if I'll show you that, if I want to show you that, then see this was our series, right? If you have remember, see we made the series here, right? So at the fifth step, what was our answer? 5, right? If I just put 7 here, my answer would be 13 in my question. Okay, okay. Nishant, I'll explain once again entire program. Don't worry. For which we are finding for 5 right now. I'll show you the code. Dipanshu, I'll come back to this just a second. We can also print the entire series. In fact, we did. I'll just show you that. Just a second. Okay, fine. So see, you can see my code right now. I think so. I have shared wrong thing. Just a second. Okay, can you see my developer tools right now, people? Right? Okay. So see here, in the line number 7 and 8, what was our recursive call? Okay. So if you observe in the series, if you observe in the series, like we had what 0, 1, 1, 2, 3, 5. So what we are doing, we are just adding the last two steps. If I just want 5, then I'll just add last two steps. I get to the answer. Correct? Okay. That is what I did. I found the f of n minus 1 first. I found the f of n minus 2 second, and I just made the addition of this two, and I return the answer. I can also return from here also, like fibo of n minus 1 plus fibo of n minus 2. I can also do like this, okay? But just for simplicity purpose, I did this so that everyone can understand this. Okay? Okay? Please pass the value of 10,000. Yeah, we can pass that, but I am not sure it will handle this or not. It might throw exception here. So if I just pass some bigger value like 8, okay, we seen the answer of 8. No, we have seen the answer of 7, okay, so it's 21. So if you want to just execute here, like 8, then 13, then 21, this is for my answer. Okay, if you count the step now, my 0 step, 1 step, second step, third step, fourth step, fifth step, sixth step, seventh step. Okay, fine, right? Okay, people. Okay, fine. So now, for new Dipanshu, if you just have to print, if you have to print the entire series, right? If you have to print the entire series, then in this particular recursive call, can you print the entire series here? We had printed the entire series in the iterative approach, but here can you print it? See, in iterative approach, what we did, we printed every time the console.log n. Okay, so whatever our value of current, we printed that every time, right? Okay, so why cannot we print like this? Can we do this or not? And instead of this return, we will not return anything. Okay, and instead of this console.log, we will be like just calling like this. Can we do this? Can we do this? Everyone, I want answer from everyone. Think about it. Why you did not use curly braces? Because we just have one statement here. Okay, whenever we have just one statement, Ankit, we can omit the curly braces. Fine, right? Yes. So instead of the n, if we print the response every time, can my job will be done? Yes or no? Right? So if you just have to print this, see every time it's print NaN. Why? And print 1 every time. Why it is doing like this? Guys, I'm giving you some time. Why it is printing like this? We have to think together, right? Because of response. Okay. Recursion not working as return in is commented. Okay. So instead of that, what we should do, if we just have to print the entire series, so this return should every time should come, right? है ना? Okay, that's a great solution. This is like an interesting one. So what he's telling, Aradhya is telling, we should return console.log response. It should work. It will work or not. So suppose if I'm just doing this, so it is just printing out the series, but it's infinite time, I guess. So not infinite time, but it's printing some weird values, right? 1 2 1 3 1 2 1 5. Note here, we have not handled anything in the base case. Can we use array and push? Yeah, you can do it. That's also a great solution. Great Nilanjan. That's also a great solution. Deepak, we have to use recursion two times because we have to add two numbers, right? We have to add these two numbers. That is why. Okay. So what we should do here? So Nilanjan, suggest for you if I just take like this. Let array is equals to empty. Okay. This is my empty array. Okay. So if I just push my array every time, okay. So whenever I'm returning this, before that I'm just pushing every array dot push and my response. Fine. Okay. Fine. And can I have to insert here? Can I have to insert here? But but there is a catch here. Can anyone observe here? What is the catch? Okay, so I'm giving you some 5 minutes. Okay, I'm giving you 5 minutes. Everyone, please try to solve it. I want this entire series to be printed. Okay, I'm giving you 5 minutes to think on it. It's very easy. You are just about to reach there. Fine. Yeah, I'm pasting the code entire. This is our code. What we have just did. Vishal, for using for loop, we already did, right? We are here. We are just using the recursion to solve the same problem. You can use the for loop, but not for the main purpose. Okay, you have to use recursion. Okay, Ankit. Okay, guys, time up. Can I tell you the solution? Can I tell you the solution, or you want still want to try? Trying? Okay, ठीक है, try करो, no problem. Otherwise, I'll tell you the solution. No problem. Yeah, yeah. Please, please. You can take your time. No problem. Take your time. There's no issue in that. Meanwhile, I'll just reword the code. What it was. Uh, what's this? Yes. Also, we can do that. Likit, we can also do this. Otherwise, I also have uh, another solution for this as well. I'll tell you this if anyone else done. So if you have core concept of Fibonacci, like recursion is clear, this is pretty easy for you. ठीक है. See what I'm suggesting is, see, can you do this? So everyone else is done, or you still want some time? What is the status? You still working? Unable to do that? Fine. ठीक है. So can I do this? That, see, my n is right now what? 4, 5, right? ठीक है. Can I do this? I plus plus, and every time I'll do f of Fibonacci of I. Can I do that? It will work. Will it work? Will it work? Everyone, yes or no? Okay, let's try to run this. It was that simple. है ना? So many times what we do, we intentionally complicate the problem. है ना? It was pretty simple, right? Actually, it was also my fault because I no intentionally confused you by putting console here, by putting console here, but nobody was thinking about this. Huh? Right? Okay, clear? Good. Okay, so I'll also copy this. I'll also copy this and paste it here. Now, since since okay, Vishal, I told you I do not allow you to use a loop here. Okay, this is our core solution. You are telling me what, that we will avoid recursion and we will print this with respect to the iterative solution. You can use iterative one, but you have to use the main core concept in recursion. That is what the required thing here. That is what expected here, right? Vaibhav, if you have to put this, like if you have to print inside the recursion function. Okay, I was exactly saying what you did. Okay, yeah, yeah. Okay, so that's my bad. I was not able to get that. Okay, okay. I shared my solution. Okay, Vaibhav. Okay, so Vaibhav is saying that okay, how we can do it inside recursion function. So you have to print it inside this. You have to print this inside this. See, every time we are returning something from here, right? Every time we are returning something from here. So it's better that after you done everything from here, so if you are printing here, then you have to make a two console statement because one is from here, one is here. Okay, after this. Okay, otherwise what we have to do, after you will done everything for this particular n, the current n, then after you will print. This is a better optimum solution, right? Because otherwise you will waste your memory with respect to the two printing statements. Okay, I hope am I making sense? How to declare a variable globally, can we use, yeah, we can also do that. So if what he's saying that, so we can do like this, where array like this. Okay, and after we are finding this, we have to push array dot push response here. Okay, can we do this? Can we do this? And here we will just print our array. Can I use this one? Please think about it and then after tell something. Okay, if in case of where also you can do where. Okay. No, 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 nothing like that. Can I do that? Yeah, we have to print array. Can I do this now? Okay. Okay. So it's not like trying. Okay. So I'll try now, but it's not every time. Fine. It's printing what, empty array. Why? Function call. Yes, we did not make a function call. Okay. So we have to do fibo of 5. Okay, this is my function call. Let's try it now. It's printing the same what we did earlier, what we got earlier. Use push outside. So if I push outside, it will make no sense. Now what should I push? What should I push here? It will make no sense here. Yes or no? Okay. ठीक है. चलो. Now response is not defined. Yeah, here we have push. Response is not defined. Like this. Okay, we are getting like this now. Now what is the thing? But if you observe here, one thing, but sirs, whether we are counseling anything, we are solving. Yes, okay. But what I'll suggest is try to spend some time here. I'll just say what you can do here. Okay, I'll just give you a hint what you can do here. You can do one thing. See, first of all, you have to also push here. Okay, because you will not push here. Let's say I will just array dot push n. Okay, uh, like this. Okay, so now you are getting output like this. So if you observe here, there is a minor mistake. There is a minor mistake that you have to figure it out. How you can print the same thing with respect to the recursion in the array. Okay, we had implemented a method, one method to print it out. But if you want to do it the same thing with the help of array, how you can do it? Okay, that is your homework. Okay, will you do it? Okay, although we got the answer with the one method, but I want answer from another method as well, not just array. You can use any method. Okay, you can use any method you want. Fine. Nilanjan, you did it great, but don't disclose it. Okay, because everyone has to try. Fine. Okay, can we go? uh, can we go further? Yes or no? Okay, I'll paste the original code. Don't worry, I have made this inside my VS code, so I'll commit it after the session. Fine. Okay, now since we are clear with this, what I will suggest now, that just one problem from basic is left. Okay, then after we will move to the intermediate solution. This was also basic one. Okay, now there is also one more basic problem that I have currently. I'll give you that. And this is also a very simple one. Okay, so if you observe till now in recursion, just understanding the problem part is a difficult one. But after you got the logic, after you got the gist what is my smaller problem, then you are good to go. Yes or no? Solution is pretty simple, code is very simple, है ना? So now my question is, let's say if you have let's say if you have an array of size n. Okay, I'll give you the array of size n, anything, right? So you have to check if my array is sorted in ascending order or not. Basically, what is my array sorted or not? Okay, okay. Suppose my example is like 5, 4, 3, 2, 1. Okay, if I give it this input as my input, your output should be what? False. If I give you another input, if I give you another input, let's say uh, 1, 2, 3, 4, and 5, your output would be true. Okay, this is what is expected. Okay, and trust me guys, this is a basic one. This is not a tough problem. Okay, so I'm giving you some time to think on it, then after we'll discuss it, then after we will solve it, and then after we'll take a break. Okay, so this is your question number 2 for today. I'm giving you exit 4 minutes to think on it. We'll be coming back at 9:20. Okay, question problem is clear for everyone. Nilanjan, it is clearly written, right? So you have array of size n. You have to check if array is sorted or not. If this is your input, this is not sorted array, your answer would be false. This is my sorted array, your answer would be true. Okay, fine. With recursion, we have to do it. Yes, with recursion, we have to do it. Okay, that is of course thing, right? Obvious thing. Sorted in ascending. Okay, so If I'll just write sorted, that does mean that ascending. If I want in descending, I'll explicitly tell you that I want in descending. But since you have asked, I'll just add ascending. Okay. You can also see from the sample output, it's my descending order. My answer is false. It's my ascending order. My answer is true. Okay. Fine. So take your time. We'll be coming back after 4 minutes. 9:21. Again, guys, I'll tell you that try to figure out the bigger problem. Try to figure out the smaller problem. You are done. Okay. Time is up, people. You got the solution? Any one of you? Uh, I want the smaller solution only. Yes, yes, yes. Nishant is exactly right. Okay. Nishant, this is what we have to do. Okay. Great. Dipanshu, please do it if you want to do it right now. Okay. Shubham, you can also take some time if you want. No problem. I'm giving you 2 more minutes. Please try to find it out. I just want the smaller solution. Okay. Just like in the Fibonacci, We had f of 0 as 1, f of 0 as no 0, and f of 1 as 1. Same way, I want a smaller solution in this. Okay, Vishal, have you used recursion in your solution? Cannot see the recursive call. Like you have used the function of each sorted. Have you used that for every calls? I then I think I must be seeing the smaller code of it. I cannot see the entire code. Okay. No, I cannot see the entire code. But if you have used that, that's fine. Okay, Shivam, I think it will work. It will work. The approach is right. Some mistake here and there, I don't know, but approach is all and all, it's right. Okay, nice. So I see the new phrases coming into the picture. That's really nice. Okay, keep going on, people. Shivams, I told about the Shivam in the last one. Okay, about the approach, I told about the Shivam. I cannot see your code entirely, Vishal. I don't know how. I don't know why. Okay. Anyway, okay. So, uh, guys, let us start. Okay. Then after we'll focus on. Then after I'll give you another problem. In that you can take your time. Okay. Because this is kind of simple. Okay. Okay. So you can see my OneNote screen, everyone. Okay. So now, anyone who is still trying, please try to see in my code, like see in my screen. Okay. We will solve it together. Another problem. Fine. So for now, suppose if I have my big problem as 1, 2, 3, 4, 5. This is my bigger problem. Yes or no? Now the question is, what could be my smaller problem? This element now this is having 5 elements, right? This is having 5 elements. This is my bigger problem. Now, what could be my smaller problem? Smaller problem could be what? Priyanshu, I just told that no, this is my bigger problem, right? This is having 5 elements. I need to find whether this is sorted or not. This is having 5 elements. Is this my bigger problem? Yes or no? I need to find somehow the smaller problem in order to work with recursion, right? I don't want code. What is my smaller problem here? Okay. So if I say that if I have just one element, okay, I will just have one element like one. So one is sorted. Yes, right? Okay. Now this one will be returned to its caller. Suppose that number is 5. Okay. Suppose 5 has called 1. Okay. Now 1 will be returned to 5 and it will compare itself whether I am smaller than 5 or not. If I am, then I'm sorted. If I'm not, then I'm not sorted. How many of you are clear with this approach? Or should I make it more simpler? Should I make it more simpler? Okay. Okay. So Just a second. Okay, so I'll make it a more simpler thing. Okay, so what I told just now is, let's say I have five elements, right? So for to figure out the five elements, there is more. This is a like very crucial process, right? Okay, to figure out the five elements. Now, what about how about that I will be solving this four elements only. Let's say this five elements is sorted or not. It's job of Dipanshu. Okay. Now again, Dipanshu is lazy. He has passed the job to Priyanshu. Now what Dipanshu will say to Priyanshu that you have to figure out, Priyanshu, you have to figure out that 2, 3, 4, 5 is sorted or not. Give me that answer, yes or no. I will compare your answer with my element, like 1. Okay. I'll compare that with 1. Okay. If my element, you whatever your element you will return, let's say you will return my second element, right? And my element is what? First element. So I'll compare whether my first is less than second or not. Okay. Okay. If the answer is yes, then my element is my array is sorted. If answer is no, then my array is not sorted. Okay. Now similarly, Priyanshu will pass on this task to Ekta. He will say that, hey Ekta, you can figure out 3, 4, 5. Is sorted or not? Give me the answer. I'll compare it with my element, which is 2. Okay. Priyanshu's element right now is what? 2. Okay. He will compare that and find out the answer. Now Ekta will again pass to someone else, someone else. Now the last whoever will be the easiest process for him. Okay, because he will just have the last number with him to figure out the last element is sorted or not. It's pretty easy, right? Okay, it's pretty easy to sort it. So to find the whether five is sorted or not. Five is always sorted. Like one single element is sorted. Okay, you will return that particular element to the caller. Okay, he will be having the element of 4, right? So now he will compare whether 4 is less than 5 or not. It's true, right? So he will return back. Now here, here the element will be 3. Now 3 will be comparing with the 4. Now at any point of time, if I'm getting answer as false, I need to return back that my answer is false. Correct? Now it's much clear. Okay, right? So here my base case would be what? Here my base case would be what? To figure out a single element only. This will be my base case. So if I have to just figure out, like if I have to just simpler tell you in the simpler way, more simpler way, then what I'll tell, let's say if I have a function in my, let's say I will pass my array and I pass my index. Okay, this is what my bigger problem. Now I need to make it in a smaller problem. Now my smaller problem would be what? To figure out array, but my index would be what? I plus 1 now. How many of you is clear with this particular statement? First of all, I need to pass it out with the bigger index. Then after my index would be increasing and it will be become my smaller problem. So it will be my smaller problem. Now the answer would be here would be either yes, either no. Okay. If my answer is yes, then I'll compare if my array of let's say I is less than my array of I plus 1, yes or no. If answer is yes, then my element is sorted. Otherwise, it's not. If my answer is no, if my answer is no, then I'll straight away tell that my array is not sorted. Okay. So basically, uh, if I want to tell you, then you are just comparing out of this. You are just comparing every element to everything else, right? So first of all, my recursion would be made with the one. Then it will be smaller would be this. Then after I'll take 2, smaller would be this. Then after I'll take 3, smaller would be this. Then after I'll take 4, smaller would be this. This will be returned to 4. We'll compare whether 4 is less than 5 or not. It's true. It will be returned to this. Whether 3 is less than 4 or not. It's true. Return to this. 2 is less than 3 or not. It's true. Return to this. 1 is less than 2 or not. Return true. Then after my answer is this is how it's working. Okay. Okay. So should we move to the implementation part, people? Right? It will be much clear if I implement that. Fine. So let me implement that particular thing for you. Uh, I'll go to the developer tools. Let me know once my screen is visible for everyone else. Screen is visible for people, right? Fine. So the implementation part is pretty easy. It's really simple. Okay. Now I'll check whether my function is sorted. Then after I'll take my array and my index. Okay. Fine. Now here what I'll check, my I will check my return, my base case. Okay. So I'll whether suppose if I'm passing what 1, 2, 3, 4, 5. So at the end of the day, you have to figure like what whoever was figuring out the last element, the simpler task, the easiest process for him, right? He will be figuring out the last element. Yes or no? So I'll just write it here. Whether my array of I is equals to or else my index, not array of I, my index is equals to my array dot length minus one. Okay, right? This is how I can fetch my last index, right? Okay, if my array is in my last index, so that does mean that I just have one element inside it, right? So what I'll do, I'll just return true from that. Okay, this will be my base case. And this will be my base case. Now in the recursive call, what I'll do, for every element, for every other element, I'll take is sorted array, and I'll just increase the index. Okay, I'll just increase the index by one for every time. Okay, so let's say if I first of all I had the index of 0. So if I have to write it, then I'll just call my element, call my array here is sorted with the array 1, 2, 3, 4, 5, and the starting index would be 0. Okay, so that I'll pass 1 from here. Okay, if I pass from 1 from here, it has to call another thing, right? It has to call 2 to 5. Okay, so it will call 2 from here, it will again recursive call 3 from here, 4 from here, and whenever it will be calling for 5, it will be returned true, right? Okay, now this was my like base case and recursive call. The self work is yet remaining, right? So what would be in my self work? Okay, after anyone will return to me, what will be my self work? I'll just self work would be what? I'll just check my value. First of all, whether anything is written on my value or not. It should be true. Okay. If my value is true, that does mean that 5 has returned me true or not. 4 and 5 has returned me true or not. If any element is returning false, then I'll straight away tell that my answer is what? False. So I'll just return false for that. For everything else, if they have returned me the true element, okay, that does mean that my value is true here. So I'll check value is true, yes. Then I'll check again if my current value is less than what it is returned, right? It I plus 1 or not. If yes, then I need to return what? True. This is the thing, right? And finally I need to do a console.log here. Okay, right? So this will be what my recursive call. This will be my self work. Now it will be working like this. So if I run this out, it will be true. And if I just make this array is like 10, then uh, 1, 15, or 54, and 5. This array is not sorted, right? So it should return false. Okay. This is how it's working, right? Repeat if part. Okay, fine. So this if part, right? So what does this mean that Priyanshu? That whenever you are returning the final element, let's say this was my original array, right? So I need to make repeated call until I reach here. Agree with me, right? Yes or no? Yeah, I'm telling you that only. Okay. So whenever I'm doing repeated call, recursive call, I need to, my target is to what, hit the base case, right? So that does mean that I need to go in the deepest level, right? So I need to go till my files come, right? My last element. Yes. Okay. Whenever I'm reaching to last element, it will hit my base case. It will return true from it. Okay. Whenever it will return true from this, I need to compare this element to this, right? This both should be compared. Yes or no? Right? If 4 is less than 5, then I should return again true to this. Yes. If this is not true, that does mean that I need to return false from here. That is what I have returned here, right? Now let's suppose it is returning me true, right? It is returning me true. So I need to compare this element to this, because this is already been no compared with this, right? Okay. So I need to compare now 3 from 4, right? Okay, eighth line will hit to base case. No, eighth line is what my recursive call. It is made to go at the deepest level. When my base case will hit, after I'll recursively call every element of it by using I plus 1. Okay. So if you observe here, I'm increasing my index every time. I have started from 0. I have started from 0. I'm increasing every time my index, right? Till the time I'll not reach to the last index like this. Whenever I'm reaching to the last index, I'll return true from it. Correct? Okay. If you just see it out in the practical way, debugger, let's see it out. Okay. See what I'll do. I have called my array, right? This is my array. This is my index right now, 0. Now I have called again my is sorted, right, with array and I plus 1. That is what my first index. I'm calling again with second index, right? Okay. Yes or no? Is this the optimum solution? On getting whole, it's confusing. Okay, fine. Let me make it more clear. Make it more clear. Okay, just a second. Copy this everything. I'll close this and I'll share my screen of. Just let me know once you can see the screen of Chrome. You guys can see the screen of Chrome right now. Okay, guys, please wait for a minute. We have to solve this problem. Then after I'll give you the break. Okay. Okay. I know you guys are must be hungry, but see, this is very important. Okay. So I'm copying this. I hope you my screen is visible. So what I'll do now. Okay, this is my call stack here. Okay. Right now my I is 0. I am sending in this. Okay. I will compare whether it's my last index or not. It's not, right? So I'll make again call. I'll make again the call index, like I'll increase the index every time, right? Okay. Till the time I'll not reaching the final index. My I plus 1 would be 4 now, right? So this is my final index, right? I'm reaching at my final index, correct? Okay. So I'll return true because my element right now is what, 5. If you just want to check it out, then you can just check it out the array of I. What is the value? It's 5, right? It's my last element. So whenever you have just one element to compare, it should return true. Correct or not? Yes or no? Everyone, everyone. I want answer from everyone. It will return true. Base case is clear. Okay. Now what I'll do after I'll return true from this, what it will do? It will return from this. Okay. From 4, it will return to 3. Okay. So this I plus 1 for the I equals to 2. That does mean that for this call, I will I will be getting what this well as true. Yes or no? Yes or no? right? So see here. So whenever I'm returning true here, okay, I will be 3. This val will be what? True. Yes or no? And the I of 4 has removed from the call stack. Everyone is with me right now? Yes or no? Correct? Okay, fine. So now since my val has returned true, but I need to also check whether it's 4 and 5. Between 4 and 5 also I need to make a comparison, right? So that does mean that you have to return true from the last element, as well as you have to check with the current element as well. Okay, so what I'm checking right now, my current element is what? 4, and my plus 1 element is what? 5. So I need to check this element with this element whether 4 is less than 5 or not. If yes, and if my previous element value was true, then I need to return true again. Yes or no? Right? Yes, Ankit, that's the case. Okay, so now this return value true would be gained to the I equals to what? I currently my I equals to 3. It will be returned true what? I equals to 2, right? Okay, so if you check it, this I will be 3 will be removed from the call stack. It will be returned to this particular call. Okay, so now see, this is my I equals to 2. 3 was removed. So for I equals to 2, my value equals to true. Okay, because I have returned true from the previous scenario. Okay, so I got my value equals to true, but again I need to check the current element, which is what? 3. So if you check it, this current element would be what? 3. So I need to make a comparison of 3 with 4, whether my 3 is less than my 4 or not. If yes, and my previous element was yes, previous call value was yes, then I need to return true. Yes or no? Okay, so it will be returned to the calling of the 2. Okay, I equals to 2 would be removed. Okay, so if you check it out, I equals to 2 was removed, and my current element right now, my previous elements call by making this would be true because I returned true from that call, right? And I again need to check the 2 with 3. Okay, because I need to check current element with its greater element whether it's greater or not, because rest of the element would be anyway checked and it's returned true. So I need not to make comparison of this element. I just need to make check of my current element to its next element only. I hope this is clear. Okay, Aradhya, we have to write if in the val because we have to check whether our previous comparison was has returned true or not. Okay, if our previous comparison has not returned true, so there is no sense to check the current element because the previous comparison already returned false. So we have to return from that and we have to just end the process. That's all. Then it should stop. Yes, it should stop in that case. Okay, so now we are standing at I equals to 1. Our previous calling value was what's true. I need to check my current element that is 2 with the next element that is 3. So it's again return me true. Okay, okay, so now my I equals to 1 call will be removed, and now my I equals to which will be my final call. Okay, so I will be checking the value that was returned from the previous case, which is true. My current element right now would be what? 1, and I will just check it with the element which is 2, which is true. So I'll just return here which is true. This is how it's working, and it will be also removed from the call stack. I hope this is pretty much clear now. How recursion happens after return true? So Parag, recursion will happen after return true because let me show you that as well. See, right now I am standing at value 5, right? Okay, this is my final call, right? Yes or no? No, because I have pass index of 0, right? So I'm standing here. So now for every call, it will be increasing the index till the time it will reach to the final case. Okay. Now I'll show you that. Just a second. Okay. Like this. Now, once I'm returning true from this, that does mean that this element has returned me true, which does mean that anything after this is sorted. Okay. Parag, can I say that anything after this is sorted? After phi anything is there, it is sorted, but right now I'm just having one element. That does mean that phi is sorted because phi is just a single element. Yes or no? Parag, are you there, Parag? Yes, ठीक है, this is my base case, है ना? So after it returns me true, after it returns me true, I just need to check with the 4 whether 4 is less than 5 or not. Just I need to check this because anything after 5 is already been sorted. The same case I'll go with the 3. I'll just check with the 4 only. Anything after 4 is already sorted because it has returned true from this. It have if it has not, it will be break the loop. It will be break the recursion chain. Yes or no? How I value is increasing without I plus plus. We are not increasing I plus plus. Okay, we are making recursive call with I plus one here. If you see here, Ankit, have you got the debugging thing? What I've just shown you, right? Parag, Parag, you got the thing. What should I repeat the once again? Should I repeat the every call once again? I'll do that if you want me to. Okay, fine. So I'll repeat everything once again. Anyone who has not got or anyone who has some doubt, please see right now. Okay, see. So now base case is clear for everyone. Why we are writing this? Why we are just comparing with one element? Why we are just comparing index? Whether my index is last element, then I need to return true. This is clear for everyone because I just have one element. That is why I'm returning true. Okay. Okay. So my main motto. Just a second. I need to recall it. My main motto of this recursive call is to go till this point because I need to return true from this. Yes or no? Right? Okay. My main motto, first of all, my main goal would be to reach at the last element because whenever I'm reaching at last element, I need to return true as per my base case. Is it clear? Am I clear, people? Okay. This point is clear for everyone. Yes or no? Everyone. I want answer from everyone, not from just 5 to 10 people. This is true, right? Because if I'm standing at my last element, then I anyway return true because there is nothing to compare. Yes, okay. That is what my base case is. Okay. So right now my I is what 4. So this is what my base case is. So I'll return true from this. Okay. So my first job has been done to return to go to the base case. Okay. So now my 5 is sorted. Now I'm just left with this 1 to 4. Correct or not? Okay. Right. So my 5 has been compared with itself, right? I'm just have to compare this 1 to 4 now, right? Okay, so my smaller problem has been solved. What I'm right now doing is I will return this true to its caller. Now who has called this return, like who has called this particular I equals to 4? Okay, I equals to 3 has called now. From I equals to 3 only I have called I equals to 4 by this I plus 1. Yes or no? So that does mean that this 4 has called 5, right? So now I'll just compare the 4 with the value of 5 if 5 has returned true. This statement is clear. This statement is clear. If not, just tell me. I'll repeat this once again with the flow, everything once again. No issues in that. I want answer from everyone. Nishant, I have not reached right now with the ninth line. Okay. So now let me do one thing. Let me do one thing. I'm just copying this everything and let me go to OneNote. Let me explain you the word there. Okay. Maybe you will understand that. So now everyone can see my screen of OneNote. Okay. Guys, please ask the question till the time you don't understand the concept. Okay, it's perfectly fine. I'll be more than happy to explain you 100 times. Okay. Now see, this was my code. Okay, now forget about this code. I have what 1 2 3 4 and 5. Now if I just compare, if I just compare the element of last element, which is my 5, it should return me true, right? है ना? This was my base case. I'm just left with 1 to 4. Okay. By any chance, I'm getting chance that no, my 1 to 4 answer is true. So I should just return true from this only, because 1 to 4 is true, 5 is true. So my answer, final answer is also true. Yes or no? Because I need to check whether my array is sorted or not. Sorted does mean that 1, 2, 3, 4, 5 increasing value should be there. Okay. So now, as I have checked, my 5 is true. So now only the remaining three thing is to divide this problem in chunk. Okay. So how to divide this problem in chunk or smaller problem? Just to compare one element at a time. Okay. First of all, I have compared the 5. I just have to compare the 4, but only when this has been true. Okay. So now for this scenario, since it was base case, phi itself, comparison with itself is true, I will compare whether my 4 is less than 5 or not. Okay. If this is true, then right. If this answer is also true, if this answer is also true, I will I will make this one also as true. Okay. I'll mark this one also as true, 4 and 5, right? Okay. Now if my 4, this answer is true, then 5 is also true, right? Because my 4 and 5 is also a box. Okay. I also checked everything what is right side of 4. Okay. So I need not to check 3 with 5, I just need to check 3 with 4 only, right? Yes or no? Okay. Because already I have checked 4 and 5, right? है ना? So I just have to check now 3 and 4 only. But when I should have to check only when this 4 and 5 box has returned me true. So it has already returned me true, right? So this will be returned true with 3. Now, if this is true, this answer is true, I need to check 3 with 4, right? I need to check 3 with this 4 only. If this answer is also true, I need to include this also in the box. This entire answer is what? True now. Okay. Now again, I need to check whether this box answer is true. If yes, then I need to compare with this 2 less than 3 or not. Okay. If this is true, then I need to include this in the box, and I need to just return true here. I have to just check it out that whether everything else is true or not. If yes, then I need to just check it with my element, with the my next element. If this is true, then my every element which is present here, it is true. This is how it's working. Okay, so if you see here, every time, first of all, what I did here, I went from here to here by making the every time recursive call with the I plus one till the time I will not reaching here. If I once I reach here, it will return true me anyway. Okay, so this return will true here. So here I am checking if this 5 answer is true or not. If yes, then I just have to check 4 is less than 5 or not. If yes, then I'll make this box. I'll return true here with the 3 and just check 3 is less than 4 or not. If this is true, then I'll return true. I'll make box here. I'll return true here. So at the time of 2, I'll check whether previous answer is true. If yes, then I'll just check 2 less than 3 or not. If this is true, then I'll just add this inside my box. I'll just check at the time of 1 whether my previous all answers are true or not. If yes, then I'll just check 1 with 2. If this is true, then my every answer is true. If any time, at any point of time, if at any point of time my answer is not true, then I'm returning false straight away. I will not return true because I am checking every time if this is true or not. If my previous answer has not true, then I'm just returning me false. It will be written here. How many of you are clear with this? What if our comparison fails in between? That's what I told now. If your comparison has failed, if your comparison has been failed in between, then this well would be anyway false, right? If this false, then this if condition would not get executed. This will return false anyway. This return false, that does mean that it will return directly to here, not here, but your previous call. Okay. Okay. Your previous call will check whether this is true or not. It's not, so it will return false to its previous call, till the time it will not reach to the final call. Am I making sense? To the last call stack, Dipanshu, to be honest, right? Okay, not the end of the whole process, but it will return to the final call. But it does mean that if you have this call, okay, 5 4 3 2 1. Okay, if you have this scenario, then what will happen? Your by this recursion call, it will be moving out to the last call. It will be returned true for this. Okay, now this true will be transferred to this. Now it will check, two will check whether my once answer has been true or not. Yes, it's true. And it will also check whether my 2 is less than 1 or not. It's not, right? It's false. Yes or no? Right? Okay, it's false, right? So this will be combinedly return false to here. 3 will also check whether my previous answer was true or not. It's not. So it will not execute 3 less than 2. This will not be get executed, because if you see here, your condition is and, not or. If your first condition is false, it will not go to the second condition. That is why we are checking every time this previous condition has been true or not. So this 3 will be return false from 2. It will be return 4 false here. Okay, 4 will also return false to here, and this will finally return false to here. Am I clear? Nilanjan, can you please, Nilanjan, can you please come online? Can you please raise your hand? I'll explain that. It will be much more clear to everyone. Please raise your hand. Okay. Yes, please ask, Nilanjan.
In this problem, if val is always returning true, then why should we compare with array I with array I plus 1?
Okay. So where is not returning always true. That's what I explained here. In this particular scenario, where you have 5, 4, 3, 2, 1. Okay. So tell me how the flow will happen. Okay.
In the
In
base
case of,
case, 1 will always be true.
see what I'm telling you. Let me explain you. Okay. Just a second. Suppose you have array of what? 5, 4, 3, 2, 1, right? Okay. Now
Yes, sir.
from this array, tell me how this execution will flow. What you will do if you have this array? You will first go to the this element, na?
Yes, sir.
है ना? So how you will go to this element? You will call every time is sorted element, right? With I plus 1. First of all, this call has been made with what? This element array of index of 0, right? This zeroth index.
Yes. Okay.
Okay. This will internally call what? I plus 1 every time. So it will call this, it will call this, it will call this, it will call this. Once you will reach here, this base case condition will hit. Yes or no?
Yes, sir.
It will return true.
Yes, sir.
Okay. So this base condition would always return true. Yes or no?
Yes, sir.
This will be written to where? From this element, है ना? Where it was called. So
Yes,
one
yes,
has called on this element, right? So it will return to this,
yes, sir.
right? So at the time of 2, what you will check? Your previous condition, your previous call was true or not. If yes, then also you will check whether your current element is less than your previous element or not. Okay, although this is true, your previous call was true of 1, which was your base case, but this is not true, na?
Okay,
Right?
okay,
This is not true.
okay,
So it will return false to here, right? So at
okay.
the time of 3 also you will check whether your previous call was true or not, and you will check, but this is not true. This is false. So there is no
Yes,
sense of checking this, right?
yes, sir.
This is false. So it will also return false to here,
Yes, sir. Yes,
right? Again, this will be the same case of returning me false. So it will also return false here. And since this is also false, it will false to your main caller, which was this.
yes, sir. Yes,
Clear?
yes. Yes, sir. Yes, sir.
Any
Got it.
any any sorts of 0.1% doubt, you can still ask me. I'll explain once again everything.
Sir, in the previous example where we took from 1 to 5, in
Okay.
that case, the value is always true, na?
Yes, in that case value was true. But why? See, in the previous case, this was our scenario, right?
Yes, sir.
You were calling this is sorted I plus 1 to reach here. Since
Yes,
your final call, your base case would be always true for any elements. Okay, your
yes, sir.
base case will always be true, because once you are reaching to this final element, This will return me what? True, because this is my final element.
Yes, sir.
This
Yes.
true will return to what? This. Now here you are checking the same thing, na? Your previous call was true or not? This 5 was, it was true,
Yes, sir.
right? And you will
Yes, sir.
again check whether your current element, now current element is what? 4, and now your previous element was what? 5. Whether this is true or not, it is true, right?
Yes,
So it
true.
will,
Yes, sir.
this both will be true, so it will return what? Here. Now again this will be checked whether this call was true or not. It's true. So you
Yes,
will
sir.
again check whether the current element is less than your plus one element or not. It is
Yes,
true.
sir.
So it will return to here, and finally return to here.
Yes. Yes.
Okay?
Yes.
That is why I took this negative case to explain how the negative scenario will work.
Got it, sir.
Any
Got it, sir.
any point of doubt still you
No,
can
sir.
ask
No,
me.
sir. No, sir.
Fine?
No doubt, sir.
Okay.
Thank you, sir. Thank you, sir.
Okay. Okay. Anyone else still have any doubt? Uh, Shivam, you can raise your hand. I'll explain you. Shivam, you can raise your hand, please. I'll explain you. Anyone else still have any doubt? Please raise your hand. I'll be more than happy to clear your doubt. Okay. Shivam, am I audible? Yes. Yes, Shivam, please tell. You have to raise your hand again, Shivam, because you are dropped. Okay. Anyone else still have any problem? Okay. When arrays, okay, fine. So see, Nana is asking when our array is what? 2, 3, 4, 8, and 6, right? Okay. So tell me, guys, our first main goal was what? To reach at this element. Okay, we will start from this, but recursively call will be made from I plus 1, right? We'll start from index 0. We will make index increasing every time. So from 0 to 1, from 2, 2 from 3, 3 from 4, right? 2 from 1 from 2, 2 from 3, 3 from 4. So whenever we are reaching at this particular final element, we have to return true. Yes or no? Because 6 is comparing with itself, right? So we will return true from this. Yes or no? This return true, this return true would be returned from here, right? Return to here with the element of 3. Yes or no? This is my 0, 1, 2, 3, 4, right? So this call would be returned to here. Now, at this particular call, we have to do some self work also, if you remember, right? We have to do some self work also. So here, what is my self work? My self work is to check whether my caller has returned me true or not, whether Dipanshu has returned me answer true or not. Okay. So in this particular case, what Dipanshu will do, Dipanshu will take 2 and pass 3, 4, 8, 6 to someone else, right? So Dipanshu will only be execute the his task when this will be returned true. Yes or no? For this scenario, 8 will check, this third index wala person will check whether the fourth index person has returned me true or not. If he has returned me true, then after this end does mean that, then if this is true, then after I will check whether my current element is less than my previous element or not. So for this scenario, since it has returned me true, so I'll check whether my 8 is less than 6 or not. So it will return me what? False. Yes or no, Nana? Yeah, right. So this 8 will return what? False here, right? Okay. Now since this is false, I need not to check the another condition here, because this has to be true, first condition in the self work, right? So this is false, it is returning me false, it is returning me false. So since if any element has returned you false, every element will be false, because this is the rule of the sorting criteria, na? This element is not sorted. Okay, right? Although this pair is only not sorted, but this entire array is also not sorted, na? That is why you are answering like you will be answered false here. I hope, am I clear with this, Nana? Everyone else also. Yes, Parag is right. Okay, true and then false, that does mean return false. So if you see the table of end, na, this is my end table. So 0 0, remember we have seen the XOR table. Okay, so in the end table, If your both answer is true, then and then only your answer will be true. Otherwise, if any of one answer is true, your answer will be false. Answer will be false. Answer will be false. If both is true, then only your answer will be true. This is your table of end, like this. Okay. 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 Yes or no? So in this particular condition, this particular two conditions, if your first condition is true, then only this will be true. Otherwise, it will be directly straight away will answer to false. It यहाँ तक जाएगा भी नहीं, ये second condition execute करने भी नहीं जाएगा. ये true है कि false है. ठीक है? Okay. I hope this is clear now. If you have any doubt, come after break. We will be solving that also. ठीक है? Fine ना? Okay, fine. ठीक है. So we'll be taking break for 15 minutes now. Okay, there's 10 8 now. We'll be taking break for just 10 minutes today because we have to cover a lot of things now. Okay, so we'll just take break of 10 minutes. Is that okay with you all? ठीक है, so we'll take break till okay see ठीक है, so चलो 10:20 तक हम लोग break ले लेते हैं. After we will be starting. Fine, so we will be taking break till 10:50. Okay, please go on break and come fast. Am I audible, people? Okay. ठीक है. So any doubt in the previous problem? Anyone have any doubt in the previous problem? ठीक है. It was much clear ना now. So recursion is the thing, like if you understand the concept, then it will be much easier in with respect to the coding. Okay. Anyway, so now just a second. Okay. So now since we have resolved the problem with the basic one, now I'll giving you some problem which will be like solved by you. Okay, which will be like way easier. It will be not much difficult if you understand the concept. If you, so in the recursion, your first go would be to find the smaller problem. Okay, the smallest possible solution you have to find, and then after you have to just call it again and again for every values. That's done. It's done. How we can add all the elements in array in the recursion? If you want to add every element in the recursion in the array, then you have to just call like, see, we have 1 2 3 4 5. Okay, you want to add these values in your array. Okay, so when you have to start, so at any point of time you have to have these values now, then after you will add. Yes or no? Okay. So for this particular solution, I think so iterative solution would be your choice, not the recursion. Recursion would be the one when you have to do the similar task repeatedly. So if you observe in the Fibonacci also, we have to add the last two elements for every possible solution. Okay. In this particular solution also, we have to check the previous solution and we have to compare it. If it's true, then we have to return true for every element. Okay. Now, let's suppose you have a question like this, that suppose your problem statement is you have been given a number n. Okay, so let's say I will be giving you a number n. Okay. Okay, now you have to calculate the total number of binary strings. You have to calculate the total number of binary strings. Okay, that you can generate from that number. Okay. Okay, fine. So let's suppose, and yeah, one more thing, one more constraint here, which will be that it should not have any consecutive one. Okay, so let's say for an example, if this is not clear to you, then for an example, if I have input as, let's say, I'll tell you that my number is 3. Fine. So for this particular input, your output would be what? 5. Why? Because you have to check any three length digit, any three length binary string. Okay, so for example, for n equals to 3, your binary string would be what? 101. It could be 100. It could be 010. It could be 001 and 000. Now in this particular strings, you do not have any consecutive ones, right? So this condition has been fulfilled, correct or not? Okay. So for this n equals to 3, the length of the string is 3. Your output would be what? Your total number of strings are what? 5 strings you can generate out of it. So your output is 5. Okay. Okay. So suppose for an example, for this particular example, there are total 5 binary strings of length of n without consecutive ones. Okay. So there the strings are what? 101, 100, 010, 001, and 000. Okay, so your answer would be 5. Okay, so now this particular solution, if I want to make it more clear to you, if I have to give you more explanation to this particular question, for this is not clear, then suppose if I'll say that your number of string is like your n is equals to 1. Okay, so for an example, if I'll say for n equals to 1, that means you're just one length of string, right? So one length of string would be what? 0 and 1, है ना? So our answer would be what? 2, right? For n equals to 2, for n equals to 2, your that does mean that your total number of strings you can generate from this n equals to 2, that's what? 101 and 0 0 1 0. ठीक है? ठीक है? So these things you can generate out of it. ठीक है? Similarly, you can do for n equals to 3 also, n equals to 4 also, right? So for n equals to 2, if you see, then you can generate what? Total number of strings are 3, right? And what are total number of strings? No, sorry, no, this is not. 0 0 0 1 1 0. 1 1 is there also, but you cannot consider it, right? Because there are total 3 number of solution for n equals to 2. Okay? For n equals to 3, for n equals to, there are total number of solution would be 5 if you calculate it. For n equals to 4, there are total number of solution would be 8 if you calculate it. And there are like 1010, 0101, then 0100, then 1000, and so on. Okay, right? So if you observe here, for n equals to 1, your answer was 2. For n equals to 2, your answer is 3. For n equals to 3, your answer is 5. For n equals to 4, your answer is 8. So can I say that for n equals to 3, it would be 2 plus 3. For n equals to 4, it's 3 plus 5. Can I say that? It's similar problem, right? Okay. So can you all do it right now? Pretty simple. Pretty simple, everyone. Okay, Nana, what I told you, I'll just repeat everything once again. Okay, I'll see everything once again. For n equals to 1, for n equals to 1, how many total number of strings you can generate which will not include total consecutive ones? Okay, so here 0 and 1 only. There are total number of solution would be 2, right? For n equals to 2, there is two like length of 2, 0 0 0 1 1 0 and 1 1. But 1 1 you cannot consider it, right? So total number of strings, how many? 3, right? Rupesh, Naina, Niranjan, Priyanshu, Deepanshu, Deepak, everyone, right? This is included in the question, Rupesh. If you see in the question, there is C in the question that is written here. Not do not consider consecutive ones. It should not have. Okay, so you need not to consider that. That is written in the question. Otherwise, you can also consider that as well, Rupesh. Right? Okay. For n equals to 3, if you calculate, total number of solution would be 5. For n equals to 4, it will be 8. So can I say that for n equals to 3, it will be summation of 2 plus 3. For 8, it will be summation of 3 plus 5. For 5, it will be summation of 5 plus 8. Like that. ठीक है? एकता, Nana. Okay. So you can implement that right now. Okay. Yeah, it's like Fibonacci series, but the base case would be different here. Okay. In Fibonacci, it was 0 and 1. For 0, we need to return 0. For 1, we need to return 1 in Fibonacci. Here for 1, we need to return 2. For 2, we need to return 3. And for everything else, we need to return n minus 1 plus n minus 2. That is what our solution is. Correct? Okay. Except the base case, everything is same as like Fibonacci. है ना? Yes, base case will be changed. Pretty easy. Doable? Yes or no? Okay. So can I make this as homework? Can I do it as homework? Right? Okay. ठीक है. So question is clear. Solution is also clear. We need to move another solution. Can I move to the another question? Can I move to another question, people? Okay. ठीक है. Great. चलो. fine. So my another question would be, let's say, yeah, this question I need to. This is very super question, huh? Must the question. Finding a subsequence. Okay, so suppose, if you have, like, I'll just brief you around this particular question first, then I'll make you to solve this. Okay, so let's say I have an array like this one. Please focus on this is very important and this is very must the question, super question. 4, 5, 6, 7, 8, 9, and 10, like this I have. Okay, okay. Now what do I mean by the subsequences? Okay, what do I mean by subsequence? Okay, so subsequence, first of all, may not be the contiguous one. Okay, but like subsequences cannot be like it cannot be contiguous one, but it maintain the relative order, but it will maintain the relative order. Okay, okay. The second thing that needs to be covered in this is like elements in the, like whatever elements we are seeing in the subsequence. For an example, let me write in the, so it appear in the same order as in the original array. Okay, now I'll explain this, what I mean by what do I mean by this, don't worry. And like, for those who did not understand. Okay, and the only difference is that they might be the contiguous. Okay, so the only difference is that they might be the contiguous one. Okay, so for so what does this mean? That subsequence, that mean it cannot or it can be the contiguous one. Okay, okay, but it cannot be also the contiguous one. Okay, so let's say it cannot be also the contiguous one, but it should maintain the relative order. That does mean that, suppose if I say that 1, 9, and 10, it's contiguous or not, like it's subsequence or not. So it's not contiguous, but it's relative order na? Like 9 is coming after 1, 10 is coming after 1, so it's subsequence, but it is not contiguous one. Like 1 is not after 2, after 3, after 9. Okay, but 1 is present before 9 and 10, right? So it's like meaning of the relative order. Okay, now another thing to note here is elements in subsequence appear in the same order. So in the original array, the same way it will be appear in the subsequence. Okay, but the only difference is it's they might be the contiguous. Okay, they might be or they might not be the contiguous. Okay, it should be not here, they might not be contiguous here. Okay, suppose, now what do we mean by the sub array? Okay, so if I say sub array, let's say, for an example, if I say for an example 4, 5, uh, 7. Okay, let's say I have this example. Now, if I'll say, uh, just tell me whether it is a subarray or not, and it is a subsequence or not. Okay. So what do I mean by subarray? Subarray, that means it should present here. It should present in the array, in your original array, but it should be, it should or it should not be the contiguous one. Okay, so if I'll say subarray, then 4, 5, 6, 7 is my subarray, in is it's my subsequence also, because relative order is also maintained, and it is in the contiguous order also. So in subarray it has to be contiguous, in subsequence it can or it cannot be subsequence, right? It can or it cannot be the, uh no, contiguous one, fine. But in subarray it has to be the subsequence, like it has to be the It has to maintain the contiguous one. For an example, if I'll say 4, 6, 7. Now tell me, guys, it's subarray or not, and it's subsequence or not. What about the subarray? Yes or no? Subarray. What about subarray? Yes or no? It's not, right? Yes or no? I may or may not be confused you. Okay. So please see carefully. It's subarray or not? No, right? Because 4, 6, and 7, 5 is missing here, right? Okay. So it's not maintaining an order. So it is not a subarray. है ना? But it is a subsequence or not? Because it is a subsequence, because it is following the same order as well as the relative order of it, right? So it is a subsequence, right? Okay. Now for another example, if I'll say, then suppose if you have just a second, suppose if you have 1, 9, and 10, just tell me sub and subsequence or not. 1, 9, 10 subsequences or not, subarrays or not? What about subarray? Yes or no? ठीक है, सब array नहीं, subsequences yes, because it's maintaining the relative order, right? Now for an example, if I'll say the 5, 4, 5, 4 is my sub array and subsequence or not? Okay, both not, because it is not following any order. So sub array is not, and subsequence may it is not following the relative order also, right? Okay. Now for an example, if I have 1, 4, 7, 3, it is what, sub array and subsequence or not? Guys, I want answer from everyone. Please participate. Sorry. So both not, right? Okay, the same thing. So you're clear what do I mean by subarray and what do I mean by subsequence? I'm explaining this because your problem statement requires this. Okay. So my problem statement now is, now I'll say the problem to you, that you have been given an array, right? Inside this you have to find all subsequences. Okay. Suppose for an example, if I have 1, comma 2, comma 3, then my answer for this would be, my answer for this would be 1, 2, 3, 1, comma 2. Then I can have like every possible subsequence you have to form it from this. Okay, 1, comma 2, 1, comma 3. Then I can have 1, comma 2, comma 3. Then I can have 2, comma 3, and I can also have the empty array. Okay, so I can also have the empty array. So this 3, 3, 6, and 8. So total number of solution would be 8. So if I have this as my input, my answer would be 8. So this is my question. Okay. Now another thing to note here is, now the main thing to note here is, so for any array of length n, now I will write it so that you will remember that. For any array of length n, the total number of subsequences would be what? The total number of subsequences would be always 2 raised to n. So suppose I have my element as 3, so 2 raised to n, that is what, 8. So that is why my answer would be 8 here. Okay. Now uh, let's suppose I have my string as like only 2, 3, right? Like this, only 2, 3. So how many elements I can generate from this? Like 2, then 3, then 2, 3, and empty array. Any other element I can generate from this, right? No, right? So total number of element are what? 4. It's 2 raised to 2. That means 4. Like so, it will always follow 2 raised to n mode, right? Now, what would be the solution of this? Okay, how to find the subsequences of this? Okay, I want the every subsequences from this, not the only answer from this, not this output. Output should be not 8. Output should be this. Okay, this everything would be in my output as a string. Okay, okay. I didn't get 1, 2, 3 consider in subsequence. Okay, okay. Now, okay, fine. See, so Parag, for 1, 2, 3, how many string you can generate? You can either take 1, either take 2, either take 3, either take 1, 2, either take 1, 3, either take 2, 3, either take 1, 2, 3, or an empty array. So these all are my subsequence, right? Okay, Parag, and Navneet, subsequence and subset are not same. Okay, subsequence may or it may not be the contiguous one. Okay, as per the definition what I have just shown you. Okay, it may not be the contiguous, but relative order should be the same. Yeah, empty array would be also the subsequence now, because if I'll not choose to take any element, then what is left? The empty thing, right? Yeah, 1, 2, 3, it should be also a subarray, not subarray, it's subsequence ना. I told you subarray and subsequence both are different. ठीक है, सब अरे तो मैंने ऐसे ही पढ़ा दिया, but subsequence is what? It may not be the contiguous one, but it should maintain the relative order. ठीक है, but it's not in the array. What is not in the array? The empty string. The empty string would always be in the array. ठीक है, it always be in the substring. See, if I'll, what is the definition of sub array? Sorry, subsequence. It may not be the contiguous. So think about the empty array in this particular example. Okay, 1 to 10. So it may not be the contiguous. It may not be the contiguous. ठीक है, contiguous नहीं है. It maintain the relative order. So it is always it is also maintain the relative order also, because anything you will take empty, you will consider it before one or after one also, right? For 10, if you consider empty string, then empty string would be always come left also, it can come right also, right? It can contain anywhere in the array. It is not having any relative order. So it will maintain or not, it does not matter. Okay, that is why we always include empty array in this. ठीक है, प्रॉब्लम स्टेटमेंट क्लियर है सबको? Anyone with any single doubt with the problem statement, what we need to do? Okay, we have to generate a subsequence from this array. What are possible? Okay, what and all possible subsequences we have to generate from this. Anything apart from this you cannot generate from this, right? Okay, Nilanjan, can you please raise your hand, Nilanjan? I'll explain for you. Fine. Yes, Nilanjan. So in subsequence, see, for an example, if we have 4, 5, 6, 7, right? So we have to see the original array. 4, 5, 6, 7 are coming in the relative order. Yes or no? है
Yes,
ना?
sir. Yes, sir.
And it may not be contiguous, although here it is contiguous. So it's subarray also, it's subsequence also, right? Now think about the example of 5 and 4.
Sir,
5
one doubt is, sir, what is basically contiguous here in subsequence?
contiguous that means that one after another. Like one के बाद, like two के बाद 3 आएगा, 3 के बाद 4 आएगा. That is what mean by
Okay.
contiguous.
Okay. 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 Sir. Okay.
ठीक है?
Okay,
Clear?
sir. Okay, sir. Okay.
Okay, fine. Now question is clear for everyone. So question is clear होगा तभी आप लोग no find the solution of it. Okay. So anyone can think about the solution, or else just no. Let me give you a hint. Let me give you a hint. It will be much more clear to you if I'm giving you the hint. Okay. Can I give you a hint, or you want to think about it? Guys, कुछ तो बोल दो. Do you want some time, or you want me to give you a hint? Okay, ठीक है. So what about everyone else? I can only see the three comments from Dipanshu, Deepak, and Naina. They are telling me that they need some time. Shivam says it's done. That's good. ठीक है. So I'll give you some time to think about it. Okay. Then after we will be solving the problem. Okay. Take your time. Yes, Vishal, it's correct. Okay, your understanding is correct. No, Parag, we do not want the number of string, okay? We need the total string, not the, we don't want output as 8. We want output as this 1, 2, 3, 1, 2, 1, 3, 1, 2, 3, 2, 3, and empty array. Okay? There is no sense of putting 2 raised to n here. I hope am I making sense. Yes, Parag, correct. Guys, we are not in hurry, so please take your time and think every possible solution that you can think of. But think about the simplistic one, okay? Every time what we do, we think about like it is rocket science, so we make our mind a lot of work, but at the end of the day, it is very simple solution, okay? In this solution also, if I'll tell you, you will laugh at me that it's so simple, okay? So think about the simple solution as well. Don't every time think about the complex solution. Fine, think about it. We are not in hurry. Take your time. And everyone are trying right now, right? They are working now. Okay, ठीक है. Great. Dipanshu, am I audible? I was speaking something. I think so. I was on mute, or you heard that. So basically, I was saying that you can put inside you can put loop inside your function, but it should not the case where you are solving everything with the help of the loops or iterative solution. It should be rely on the recursion solution only. Okay, you can use the loops at just the way we did in the Fibonacci series, but not like entire solution with the loops. I hope am I clear with this, Dipanshu? Okay. Ekta, if I'll tell you the solution, na, it would be you will laugh at me, or you will laugh at yourself that you consider that as tough, and you. you were nervous by doing this. Okay, it's very easy. You just have to make it simpler. You just have to think about the bigger task, and think about how you can simplify it, how you can make this particular task as smaller, how you can assign your responsibility to someone else. Suppose Ekta has some responsibility, he will assign that responsibility to this responsibility to someone else. Okay, he will take something out of it. Let's say for this particular solution, if you have to generate subsequence of 1 2 3, you will Ekta will tell Aradhya to generate subsequence of 2 3. Aradhya will tell Dipanshu to generate subsequence of 3. Dipanshu will return subsequence of 3. Aradhya will just add 2 inside it, and he will return to Ekta. Ekta will just generate subsequence of 1 and whatever returned by Aradhya. This is how it's working in every recursion case. Yes, Ekta, base case is what, no, it's like key of this particular recursion solutions. Otherwise, you are done. Trust me, you are done. If you are getting the base case, you are just left with 5 or 6 lines of code. That's it. Okay. How many of you are trying still? How many of you are trying? How many of you are done? And how many of you are gave up, like given up from this? Done. Great. Okay. So uh, I'll say about this solution as, so can I start with the implementation? Okay, ठीक है चलो. So first of all I'll tell you the logic. Okay, first of all I'll tell you the logic as I have just instructed about this solution. Okay, I told the Ekta how to do it. Okay, first of all, let's say you have been given a task to find a subsequence of 1 2 3. Now this task I have given to Ekta. Ekta is so lazy that she will not do anything at all, but she will tell that ठीक है आप इतना कह रहे हो तो I'll just make subsequence of 1 and whatever you will give to me. ठीक है, rest of the thing I will pass on to someone else. He has to do it for me. ठीक है, and whatever he will give me I'll submit it to you. ठीक है, so fine, for suppose this finding 1 2 3 subtask is like subsequence is what, it's like bigger problem, right? ठीक है, it's bigger problem. Now what I'll do, what Ekta will do, Ekta will take this one and rest of the thing he will pass to someone else, right? Okay, so let's say she will choose Dipanshu for that. Okay, now what the Dipanshu will do, Dipanshu has 2 and 3, right? Okay, so for this 2 and 3, Dipanshu consider is as a bigger task. Okay, this is a bigger task for Dipanshu. What Dipanshu will say, I'll keep 2 with me, rest of the thing I'll pass to someone else. Let's say Aradhya. Okay, now Aradhya will just have 3. Okay, right? So from this 3, he can generate what, 3 and empty string. So Aradhya के लिए तो lottery लग गई ना, because he just have one element to be to find its subsequence. It would be what, the element itself and the empty array. Yes or no? Right? So for Aradhya, it's like a lottery case, right? He just he don't need to worry about anything else. He will just find subsequence of element itself, empty array, and he will return to Dipanshu. Correct? Right? So for our for our solution, it will be our base case, right? ठीक है? Can we consider as base case to go at deeper level to generate the self element and the empty element, right? Now this particular combination of this would be returned to him, to whom, Dipanshu, right? Dipanshu will have this particular solution now. So now Dipanshu will have, uh, as a part of three solution, Dipanshu will have what? Three and empty solution. Okay, empty array. Now he needs to find the sub array, subsequence for element 2 and this thing. Yes or no? So what he will do, he's very smart. Dipanshu is very smart. So what he will do, whatever he got from Aradhya, he will take as it is. He will make a copy of it. Okay. For one time, he will add 2 in front of the element. Now this is empty element. So if I add just 3 in front of empty element, it will be 3. And for one time, he will not add anything at all. Okay. So this is a solution of what? 2 and 3. Okay, as we have just seen here, if you want to solve the if you want to find a subsequence of 2 and 3, you will have solution of this now. 4 solution, 2 3 2 3 and empty array. So here we mistaken something. Yeah, here it should not be 3, it should be 2, right? Because in empty array, if we add 2 in front of empty element, for one time we will add 2 in front of every element whatever we have received from it. For one time we will not add anything at all, right? Okay, right. Now Dipanshu will return everything to Ekta. So Ekta will have what? This 2 3 2 3 and empty array. Okay. Ekta is also very smart. So what he will do? What she will do? She will copy this entire solution. Okay. She will copy this entire solution. She will do as it is what Dipanshu has done. She will add her element in front of every element she had. Right. So she will add one here, she will add one here, she will add one here, she will add one here. So this empty array will become 1. And for one time, she will not add anything at all. So if you see carefully, this is what is required. Okay? It was so easy. Yes or no? Okay, na? Pretty simple. Okay? So that's what I was no telling you to do. You have to just first of all think about the base case, है ना? This is what requires mind. So who has made his mind work here? Aradhya is the one who made his mind work. Although the task was so simple that he did not do anything, but he did a lot of things so that our entire problem has been solved. Okay, okay, fine. So can you make solution out of it? Like, can you code this? Okay, for just hold on a minute. Hold on for a minute. For this solution, I will code for you. Like, I will tell you the entire solution end to end. Okay, and not end to end. I'll just tell you the some solution of it, or else I'll tell you the approach for this. Okay, just a second. I'll tell you the entire solution for this. Okay, but from next problem onwards, I'll tell you the logic, and I'll expect you to code this. Can I expect that? Okay, the problem would not be that much of difficult. Okay, trust me, it will be not that much of difficult that everyone feels. Okay, you have some confidence now with recursion. Okay, it's pretty simple, है ना? Not yet. Deepak, can you come online? Can you raise your hand? I'll be happy to resolve everything you want. Like, in which particular problem, like which particular part you feel that it's not simple? Yeah, I know about the time. Okay, so do one thing. If you feel like, can I code this today, or do you want me to code in the next class? Okay, we have to code today, yeah, right? Okay, fine. So in the code, Just a second. Yeah, just a second. I'll be sharing you with you the. Mm-mm-mm. Where is Mozilla? I closed the Mozilla. How come? ठीक है. So just let me know once you can able to see the Mozilla Firefox. Can you see that? Okay. Everyone can see the screen now. ठीक है. So what we will do today is see the code. See the code how simple it is. Okay. I'll explain everything. So first of all, I'll just print. I'll just make my function as print subsequences will accept an array and the index. Now, first of all, what was my base case? Okay, so I have to figure it out. What will be my base case? So if you have seen carefully, let's say if I have an array of one comma 2 comma 3. Okay, so first of all, I had resolved every subsequences of 3. Yes or no? Right? Okay. So as per our previous solution, the same case in the base case would be done. Okay. So my index, if my index is equals to my last element, okay. So my whatever my array dot length minus one. If this is my index, this is my last index, then I need to generate what out of it. So remember, we had just three in our last element. So we had generated what the self element and the empty element. Yeah, na? Yes or no? Right? This was our base case. Okay, guys, please see carefully. If you have any doubt, please ask me. Okay, so now what I'll do, I'll just generate my base result as empty, and I'll push into it like br dot push. I'll array dot, or else like let's say I'll generate as no uh, result. Okay, so result dot push array dot array of index, so not dot dot array of index. Okay, whatever my array of index is, I need to push it into inside it. So that does mean that I have pushed three. Okay, for our case, right? And I need to push also an empty array. So whatever my empty array, I need to push array dot push empty array, right? Okay, and I need to return result. This is what my base case is. Pretty simple. That this does not have any confusion. Okay, this should not have any confusion in it. Okay, this is my base case, and in my base case, um, I need to write it like for element 3, I need to generate the self element and empty element. Okay, make sense, people? Right? Now this was my base case. This was my base case. Now the second step is what? My recursion call. You know, recursive call. Yes or no? So now my recursive call. So this recursive call would be done with which element? Would be made with which element? 2 and 3, because this whatever answer Aradhya had, he returned that with Dipanshu, right? So Dipanshu will work now with the 2 and 3. Okay, so he will do the call with 2 and 3, right? Okay, so now let uh, subsequences is equals to, I need to call print subsequences. I need to pass entire array with index plus 1. Okay, so if I'll do that, then only it should return, like it should go further na. Like first of all, I had 1 2 3, right? So I need to go till 3 as per our previous solution. So for that I need to increment every indexes, right? So therefore that I did this. ठीक है, recursive call, ठीक है. Now what will be my self work? Okay, so now what will be my work, or else my self work is equals to, first of all I'll take the empty array. Okay, now in this particular self work, what I need to do, I need to push that element, I need to push that element in the, whatever my element is, I need to push inside, like first in the first thing. Okay, so whatever my element would be, I need to push it inside this element. Okay, so my element would be lie in this element. Okay. Okay, so for this what I'll do, make a loop for I is equals to 0, I should be less than whatever my subsequences will be, subsequences dot length I plus plus. Now I just need to insert the thing here. Okay, so whatever my self work dot push, first of all I need to push what, my whatever my subsequences of I will be, right? Then I need to take a copy of my array, right? Let well is equals to, let's say, if you want to copy your entire array, na, I think so you know about this. This is operator. Inside this, we if we do this, this entire array would be copied into this. Okay, right? Now I need to insert my element at the first element of it. So can anyone tell me what should I do? If I do array dot push, it will be insert into the last. What should I do if I need to insert in the first? Unshift. Okay, great. Everyone remembers it. Okay, so this is how your fundamentals come into the picture. Okay, so whatever value will be, I'll unshift whatever my array of index. Okay, and finally I'll push into self array. Whatever will be my whatever will be my array of index would be, right? Okay, so this is the case what we need to follow when we are targeted into the following the subsequences. Okay, so whatever my val would be, finally I need to insert into it. Okay, and finally after this I need to return, let's say, self work. Okay, and I need to call this as well. So if I have to call this, then just console dot log whatever my function name subsequences, I need to pass my array 1 2 3, and here I have to pass the index. Okay, okay, let's try to run this out. What's the mistake here? Response is not defined. Where is response? Yeah, response. Instead of response, we need to take the subsequences. Okay, yes or no? Right? Yes, so instead of response, we need to take subsequences. Now if I run this, see the arrays are okay, fine. First of all, 1 2 3, output is bit confusing. Okay, so 1 2 3 1 3 2 3 1 2 3 1 2, an empty array. Total 8 number of elements are there. Okay, it's proper. Okay, I think, yeah, it's proper. Okay, okay, yes or no? This is what we just explained in the board, in the code. And I think so this is pretty easy to understand as well, right? Because you guys have extensively worked in this particular array and this kind of things, right? So this has to be clear with you. And suppose if I just pass 2 and 3, so it should generate what, 4 elements. Let's see, 2 3 2 3, an empty array, correct? Okay, done. Okay, people, yes no, कुछ तो बोल दो. Easy था ना? Subsequences, I'm copying this one. Subsequences and copied. ठीक है, let me copy this. Okay, so एक था दीपक, Aradhya, Priyanshu, any doubt, any problem? ठीक है ना, clear? Self work part, where, yeah. So see, uh, फर्स्ट गो में तो कुछ नहीं होगा ना, अभी तो हम लोग लाइक बेसिक पे है, राइट? सो दैट्स ओके, यू थॉट अबाउट दिस, दैट्स इनफ. Like, I mean, you have to thought about this, you have to think about this in detail, you have to think about this in depth. But see, this concept has been clear. So in the previous concept, if you observe, we went till the depth of the element, then we checked our value equals to true or not, and we checked with the prior element also in order to sort our element, right? The same concept we applied here with a different thing. Self work is only which is different, right? Correct. So this thing will become by practice only, है ना? This kind of solution would be applied in multiple other ways also, right? So if you understand this solution, this particular work, you can solve 2 to 3 more problems also, but you have to think on it, like where you can apply this particular knowledge. That is okay, Dipanshu. Okay, Shivam, I will see your solution now. Okay, so yeah, you made two recursive call, है ना? You made two recursive call, and error length, yeah, your condition is right, but why you have printed that console.log subsequence? Okay, fine, but how to generate the empty array? Are you able to generate an empty array with this, Shivam? I don't think so it will work. So how, like, I cannot see the code to generate empty array in this. Let me no stop this and answer it. Everyone can see the solid, like everyone can see the image. Everyone can see the image. This is what the Shivam did. This is what Shivam did. But I'm not getting how the empty array is working here. Okay. At every point of time, I am checking include that element or not. Mm, mm, mm. Okay. Okay, fine. So you had passed this empty array on the first call also, right? है ना? The third okay, fine. Got it. You are appending that. Fine. Yes. Got it. ठीक है, ठीक है. Fine, this can also be the solution, but it is having two calls, right? But that's okay, at least you have thought about it. That's perfectly fine. I'm totally happy with you. Okay. ठीक है. So anything that you want me to touch upon? Still I want to cover up some more problem, but due to time constraint, I will not. Okay, I'll share this entire PDF with you. I'll share the code of today. I have copied the code, everything. Okay, I'll share this right away. Anything that you want me to touch upon? Code, logic is clear now. How can be proficient in this kind of questions? Ikta, I'll say that you have to practice only. There is no other way. Okay, there is no other way. You have to practice, you have to fail, you have to sit with TAs, you have to sit with me, and then after you have to self practice also. There is lot more to know, do with yourself only. Okay, that will be done by your own. Okay, so you have to practice only. There is no other way. There is no solution other than this. Oh, Deepak, I think okay, fine. I'll attach this. I'll no. What I do is I'll upload this right away after the notes also. Okay, with respect, like along with the notes, I'll also upload the sheet. But I'm not sure how many of you can able to solve the sheet. Or else do one thing. We will be solving the problems from that sheet in some of the lectures, not the regular one. I will try to arrange some extra lectures for this as well, because recursion also I'm planning to arrange the revision session also. Do you guys want the revision session for recursion? Okay, ठीक है. So I will plan that session also. Also at some point of time, after some session also I'll plan some session to solve the problems also. Okay, some extra problems, or to solve some of your doubt. Okay, I'll be taking personally of your doubts. Okay, but not in the regular sessions. That will be done in the extra sessions. Okay, because if we are covering those doubts in the regular session, our regular flow of content would be hampered. Okay, but I don't want that. Okay. Okay, and whatever your like, if you want the revision session on this recursion or not, whatever that is in your call, you just have to convey the your particular thing to Anshul. He will be informing to the team, and the rest thing will be take care of. Okay. Okay, but after end of the day, everything we will do together, but you have to practice also, है ना? There is no escape from this. There is no escape from this by any chance. Okay, so whatever I told today in the beginning of the session, whatever I'm telling right now at the ending of the session, that is many, like, very very important, extremely important. Please do not miss any of the session. Please do not miss the self practice of each and every day. Okay, you have to do it. You have to sit with TS. That is compulsion. Not compulsion, but those, for those who want really good results in their life, not in this particular course, in their life, they have to make extra effort. Okay, otherwise you will get the result what everyone else are no generating. If you want to generate extraordinary result, you have to work hard, extraordinarily. Okay, you have the facility of TS, right? So utilize it. Okay, fine. So every day while sleeping, before like 5 to 10 minutes ago, think about it whether I have done sufficient thing to reach at higher peak level, like to reach at that cream level or not. Okay, there are just 0.1% of people who are in cream zone in IT also, you know. So if you want to reach there, you have to make an effort. There is no other way. If there were another way, I will more than happy to share it with you, and I'm happy to move yourself in upwards in your career, in your career path. I'm here to that. Okay, but that is not, you have to make an effort to generate extraordinary result. That is all. Okay. Okay, and you are also feeling the same na, that see this kind of particular solution, this solution. Okay, this solution, think about this solution. In this solution you were about to reach there. Okay, nobody were there who has not thought about anything, you know. You are able to think, but there is like here and there, your thoughts are here and there, you are not in the proper way. But why that your thoughts are not on proper way? Because you are lacking in practice. That is but obvious, because we are doing this kind of problems first time, है ना? That is perfectly fine. Don't feel hesitated to ask doubts. Do not feel low if you are not able to solve your problems. No, this happened with me, this happened with everyone. But this cannot, like, this is not end of the world, right? If you practice every day, if you solve problems every day, if you fail, if you see where you have failed, if you work on that particular part, then only you can rise on your career path. Okay, I hope am I making sense for everyone? Okay. Okay, I want answer from everybody of you. Okay, I'm just seeing 10 to like 20 to 30% of people who are active in this session. I do not want that. Everyone has paid some money, right? Everyone is investing their time, money, and no valuable, what we can say, emotions also. Now, so do not feel hesitate to ask doubt. Do not feel low if you are not able to solve the doubts, because everyone had faced this kind of things in their career path. Okay, fine. So on that particular note, I am stopping the session. In the next session, we will be continuing to solving the more problems. Okay, okay, fine, okay. So can I stop the session now? Okay, good day for everyone. And yeah, thank you very much. I'm also feeling motivated by you guys, because you are doing your full-time job. You are at some point of time, you are also doing this as extra activity, right? So I like this kind of people who are making effort extra to make themselves better, you know. So that's great. Okay, so we will be working together, do not worry. Just work on yourself, solve the problems, sit with the TAs, sit with come up with the proper doubts, think about the solution. That is all you need. Okay, trust me, you will be in the good position after some point of time. Okay, so on that note, we'll be stopping the session, and have a great day. Work on like tomorrow you will have extra day, right? So try to revise this kind of problems, and try to come up with more solution on the particular problems. So what I have given you the homework, try to complete that. Okay, we'll be meeting on the Wednesday. We'll solve the a lot of problems in the on that day as well. Okay, good night. Okay, yeah, that's fine, Nilanjan. Parag, yeah, good night everyone, and have a great day.